This is my screencast for Project 2 Memory Manager. In this project, we are going to implement a C++ library to manage memory, and we are going to have a memory management class. First, let's look at the header file. This header file contains the declaration of the class and the declaration of these two allocation algorithms. For this class, I use a vector of block objects to track the state of memory. Each block has three fields. The first is start. This is the word offset from the beginning of the memory block. The second field is length. This is the size of the block in words. And the third field is its whole. If its whole is false, the block is allocated space. So my vector stores both wholes and allocated regions. Now let's look at the source file. In the constructor, I save the word size and the default allocator. Make sure the object starts in a clean state. And for the destructor, I simply call the function shutdown. This makes sure the manager releases its long-term memory when the object is destroyed. Next, the initialize function. It first checks if the manager was already initialized. If yes, it calls shutdown first. After that, it calculates the total number of bytes. For the extra credit part, I did some research from this website, and I use this function mmap to get the initial memory block. This function, it simply puts our total number of bytes from this starting address with the offset of 0. And after the memory block is created, I have one large hole, and that is the whole memory. For the shutdown function, it releases the long-term memory block from the initialize. To correspond with mmap function, I use the onmap function to release the whole memory. And now the allocate function. This function takes a size in bytes. My manager works in words, so I first convert bytes into needed words with ceiling. Then I call getList to get the whole list. I pass the list to the current allocator function. The allocator can be best fit or worst fit. After I get the chosen start offset, I search my vector for the matching hole. If the hole size is exactly equal to the request, I just mark that block as allocated. And if the hole is larger, I split it into two blocks. The first block becomes the allocated, and the second becomes the remaining hole. Then the free function. The free function takes an address, then I convert that address to a word offset. Then I search for the allocated block that starts at that offset. When I find it, I mark it as a whole. Then I check the block before it and after it. If the block is also a whole, I will merge these two as one large whole. And we also have this set allocator function, and the dump memory map function just writes the current whole list to a file. For the file operations, we need to use the POSIX calls, and we use this function to write the context into the file and close the file. And the getList file creates a new array in a special format to store the whole list, and this getBitmap function also creates a new array. The first 2 bytes store the bitmap size in little endian format. After that, each bit shows whether a word is used or free, 1 for used and 0 for free. These 3 getter functions are very simple. They just return to the member variables. And these 2 allocation algorithms, the best fits choose the smallest hole available, and the worst fits choose the largest hole available. Finally, for the testing part, I use this build script to compile, link the library, and run the given testing file. We can see all the test parts, all the functions are good, and the Valgrind reports no memory leaks and no memory errors. Thank you.